We have CHARM is the umbrella. Child Health Advances from Research in Mothers is the central research theme. The acronym was invented by our individual assigned to be in charge of acronyms, Jean Curver, who came up with the original Mama Bears, if you can work out that acronym, one of the greatest acronym makers that we have. So CHARM, and this is us, this is our people. And we have funding we got funding earlier as you're reading from Michigan Health Endowment Fund, and now from the ECHO program at NIH. And our two pregnancy cohorts are ARCH and MARCH. As you know, ARCH is predominantly Lansing, the 1,000 or so people who enrolled between 2008 and 2016. And the MARCH is the statewide sample, which we're still enrolling in, and you'll get some updates from Alexa and on that. And we have a rather complex arrangements with several, the initial collaboration is our 5 Michigan institutions, Wayne State, Henry Ford, the Michigan Department of Community Health, and the University of Michigan, and us, Michigan State, as well as 2 very, very important subcontracts to Rena Ficharova of the Brigham and Women's Hospital, who helps us with all manner of things inflammatory and things like that as a pregnancy immunologist, and Karen Salafia, who takes our placentas and does great things with them, and is even sending, as we speak, specimens to Georgia Bella to look at for cholesterol crystals. So all sorts of excitement there too. So this is our arrangement. The theme of today's meeting is the theme that ECHO has now made prominent for the past year, frankly, because they're looking towards the continuation of this project beyond 2023, which is its current expiration date, namely the ECHO-wide efforts, not just what we do in Michigan, but what we do in collaboration with our colleagues in other ECHO centers around the country, which there are at least 30. I think the number is 30 or 31, and they're scattered from New York to California, and we're in the middle. We're just one of 30, and they are all either birth cohorts or pregnancy cohorts. I think about half and half. So we're part of the pregnancy cohort world. We enroll in pregnancy, not at birth, and that gives us the extra information that we so prize, having the biological and the interview material available to us from the pregnancy prior to the baby's birth, and allows us to look at the child health outcomes that are the center of the ECHO program. So I will now move on to Alexa, our project director for the field, who will give us an update on how we're doing.
Alexa, you should be able to share your screen. Each speaker should be able to share their screen, just so everyone knows.
Thanks, Tracy.
Just a second. Great. Thank you for allowing me to present today on some of our project updates. I don't have a lot of time, so we'll run through these fast. And if anyone has any questions, feel free to reach out to myself or Brianna, and we can help you out. Everyone can see my slides? Yes? Okay.
Yes.
Silence is good. Okay. So first, I will update us on March recruitment. So March recruitment started in 2017. We started at Hurley Medical Center, our way all around the state in no particular order. We were paused once COVID hit and for about 6 or so months. So we've been in the field for a whole year since COVID, and have successfully recruited 216 participants during the COVID era. But this slide here shows where we finished recruitment and where we still have to go. Hurley, Munson, Sinai, Grace, University of Michigan, and Covenant over in Saginaw have all completed recruitment and also have almost completed all the births. We are almost complete at Ascension Providence Park Hospital over in Novi, finalizing some few last Detroit women over at Hutzel, and a few additional women over in Ann Arbor. We have completed Spectrum. Half the first clinic has just completed recruitment. We have been at Beaumont for a while, and trying to finish up recruitment at the first site there and start at the second site, and have also successfully recruited almost all of our participants from the first clinic over at McLaren Port Huron, which was our last hospital that we onboarded. And we're getting ready to actually jump into the second clinic there with Dr. Barone's help, engaging the clinic. So the left here that shows recruitment, the shading shows how close we are to being completed there. Our target recruitment end date, and then the births that we still have to go at each hospital to get the children into the study. We've had to shift some of our target recruitment end dates, but we hope kind of completed with the actual recruitment portion by the fall of 2022, depending on the engagement of a few last clinics. Okay, so the participants, we have recruited 872 active pregnant mothers. And what that means is they're either currently pregnant in our protocol, or they have delivered, 733 have delivered babies into March. We have actually recruited 1,052 participants, but because of withdrawals, miscarriage, and out of sample, meaning they did not deliver at one of our sampled hospital, that number drops down to 872. This is just a table showing you what protocols we have in prenatal and the amount of information or samples we have in each of those protocols. We have well over 1,000 prenatal surveys, with that third prenatal survey going into the field about 9 or so months ago, maybe. We've successfully collected almost 2,000 urines, bloods, of course, being a little bit more difficult since those have to be done when the clinic collects their blood. We can't do an extra poke, but we do have over 1,000 bloods, over 500 placentas. And then the hair and toenail protocol here, we implemented because of the echo-wide protocol. They are difficult to acquire from participants remotely. This is done at home and they're sent to us, but we continue to try to engage the participants and see if they will send those samples back so we can send them off to echo. All the urine and blood eventually will make their way to echo, and through the type B to type C conversion, and also some type C specimens there. If I won't get into those definitions, but some of you may know what that means. And that is inaccurate. That's as of recent. But I will turn it over now to Brianna to talk about what the children in our studies have been up to.
Great. Okay, so we'll start with our March postnatal follow-up here. So we have a table here on the left-hand side. You'll see the survey protocol, followed by the total number completed for each survey protocol, the percentage completed, and then on the right-hand column here, we just have important data elements within each survey. So as you can see, our 3-month survey, which is completed over with SRC at the University of Michigan, that is currently at 71%. Our 9-month survey, which after the 3 months, the surveys kind of come back over to Michigan State and our study office. The 9-month survey is currently sitting at 82%. Our 2-year survey is sitting at about 70%. And the 3-year survey, which as you can see from our total completed number, Only more recently started with that protocol. The 3-year survey is at about 46%. The 4-year survey, which is kind of hard to believe that some of our March kids will be turning 4, that will begin in 2022. And the 4-year-olds will go back over to SRC, and U of M will be completing their in-home assessments along with the 4-year survey. So we don't have any of those completed yet, but those are set to start at the beginning of next year. Next slide. So here we see a slide of some numbers for our postnatal March biospecimens. So at the moment, we're collecting the following biospecimens from our March participants postnatally. We have our 3-month stool sample, our 3-month toenail sample, and our early childhood hair sample. It's important to note that the 3-month toenail and the early childhood hair protocols, those were introduced only as of recently to comply with our ECHO-wide protocol. So far we've collected about 314 3-month stool samples, 24 of our 3-month toenail samples, and 85 of our early childhood hair samples. Okay, and lastly here we have our ARCH follow-up. On the left-hand side, we'll see each protocol, and on the right-hand side, we see completion for each protocol. So at the moment, we have 535 ARCH participants who have consented to the ECHO program. Out of these 535 participants, we keep a range of 85 to 91% of them are up to date with their annual surveys, meaning they've completed their most recent annual survey for us. The next 2 rows here show our in-person assessments and our remote assessments. So pre-COVID-19, we were doing the majority of these assessments in person. During the beginning stages of COVID-19, we did move to remote assessment completion for most participants, just because we couldn't see participants in person at the time. And during these assessments, we'll collect biospecimens, we'll complete anthropometric measurements, we do some surveys with the participants, and then we complete their cognitive assessments. So we've had 61 participants who were able to come in person and complete their assessments, and we've done a remote assessment on 62 of our participants. And then lastly, for ARCH, we have collected 354 total teeth from 108 participants. I guess, and just as a general note, like Alexa said, if you have questions about any of those follow-up numbers for either ARCH and March, please feel free to reach out and I can send some more detailed explanations for each of those.
Okay, so.
Does George Abella have a question? I thought I saw his hand raised. You're muted.
Yeah, just out of curiosity, what do you do with the teeth and the hair and the toenails? What are you looking for? I'm just curious.
Good question. Do you want to answer, Alexa or Brianna, or shall I try to answer?
I was going to answer most of those are going to ECHO, but if you'd like to get a little bit more in depth with that.
Really, at this point, for some of these specimens, they're really being archived for future hypotheses, really, that are not so clear. Just probably the bulk of the material will be used to look at forms of environmental exposure that can be measured or other related things like that, George. These big, large studies often they're not quite as full of hypotheses as perhaps you or I would wish. I've had this argument for many years now, going back to the National Children's Study days, but there is some value to putting things aside and then assuming that you have in your head some potential use for them. I mean, the teeth are
toxins or other.
Yeah, environmental toxins especially, but as well, perhaps inflammatory biomarkers as well. Perhaps measures of stress, cortisol, catecholamines, all sorts of things could be measured. Drug exposures can be measured in hair. So there's a whole range of things you can do with these items.
In an interest of time, Nigel, I'm going to go ahead and move on if that's
Please, go right ahead.
So I'm just here to give you a really quick update on our interest groups and collaborations. So we have several interest groups, and here you can see the ones that are currently active. We invite you to email me, and I can put you in touch with the leaders of those groups to add you to them. The newest one is the marijuana interest group, and they're interested in having more people join that group. These groups are pretty active and looking at lots of different ways to utilize not only our data, but potentially look at what they want to do within our data and then move on to echo-wide collaborations and put in echo-wide proposals. So just quickly, the microbiome group with Sarah Comstock, the PFAS interest group with Mike Petriello, marijuana interest group, which I just mentioned, is these three have just started. Patty McCain is overseeing our health services and public health interest group, and Nigel's working with the placenta interest group. So if you are interested in becoming a member, please just shoot me an email and I will facilitate that. And then the second thing I'm hoping to just bring up with you guys is trying to quickly outline our process for using charm data and or biospecimens. So we have put in place a process to access those that we hope is easy and is that you guys can understand and see, and we tried our best to make it quick and easy to use. But of course, there are steps to it. So, but first, you would just request an approval for your concept. And that is online on a form on our website, which I can show you and send out. When I send slides, I'll send you a link to that. Once you've received approval, you would get a number that you should save. And once you have received that approval, you need to go through the process if there is necessary IRB or MTA or DUA requirements for that. Once that has happened, then you would use that approval number through a second form just to request the data. And that's where you would put in details like the specific data from the data dictionary, or specific like amounts of or volume if you're looking for a biospecimen. And we ask that you all use our prescribed acknowledgement, because that's one of the ways that ECHO judges how we're doing. That those allow us to pull the publications that you're doing. Oh, I should mention step 3 is once you have completed your assessment, obviously ECHO has its own publication committee, but if it's not an ECHO-wide publication, we ask that you send manuscripts or abstracts to us before they're submitted. Again, we try to do a really quick turnaround on those. And of course, in those, we ask that you use the appropriate acknowledgement, since that's how we keep track. We ask that you don't contact the data managers directly. Sometimes there are only a few of them and they get overwhelmed by that. So we ask you to kind of come through some of our other study office people, myself in particular. And we wanted you to know that we're really excited to see the data that we've worked on collecting being used and sent out for publication and as abstracts and talks. So thank you very much.
Just downsize this. Okay, so my name is Gail Shipp. Good afternoon. I want to thank you all for being here today. I am actually one of the Echo Diversity Supplement recipients, and today I'm going to present on understanding breastfeeding practices among Echo cohort participants. And so within the supplement, there are two projects that I wanted to share some preliminary, and again, I emphasize preliminary results on. So I'll talk a little bit about exclusive breastfeeding protection in childhood obesity, which is one of the research topics. And then I'll come back a little later and discuss another research topic, which is focused on COVID-19 effect on breastfeeding initiation and duration. And so childhood obesity is one of the most serious public health challenges, actually worldwide, where the prevalence has increased at a pretty alarming rate. The World Health Organization has shared that the total amount of children under 5 with overweight and obesity has risen from 32 million in 1990 to 41 million in 2016 globally. And it's projected still to nearly double, reaching 70 million by 2025. Unfortunately, childhood obesity is linked to several physical as well as mental health conditions, some of them including sleep trouble, depression, anxiety, and diabetes in childhood. And so adult overweight as well as obese children are typically more likely to become obese in adulthood. And so without having some interventions, it'll likely continue from adolescence, again, into adulthood, where adults are likely to develop a variety of physical health problems, in which adult overweight and obesity has strongly been correlated with chronic conditions and diseases such as diabetes, hypertension, cardiovascular disease, certain types of cancers. And again, the World Health Organization recently shared that the number of obesity-related deaths is estimated at 2.8 million per year. And so the mechanism of childhood obesity development is still not fully understood. There has been shared, there's multiple causes, some of them including genetic factors, the environmental factors, as well as some personal behaviors, dietary habits, and all of their interactions. Over the previous decade, though, there has been a growing body of research which has indicated that breastfeeding has been identified as a potential protective factor for childhood obesity. In many studies, while there has been other studies that failed to establish an association between breastfeeding and childhood obesity. And so, as you all know, breastfeeding provides many essential benefits, particularly nutrition. It's the ideal food for infants. It provides adequate energy as well as nutrients to meet that infant's needs. And it provides many documented physiological as well as developmental benefits for the infant. Moreover, there has been long-term benefits documented as well throughout the lifetime, some particularly documented as lowering the rates of overweight and obesity, and again, type 2 diabetes and hypertension. With that being said, the American Academy of Pediatrics recommends exclusive breastfeeding for the first 6 months, followed by continued breastfeeding as those complementary foods are introduced, with the continuation of breastfeeding for a year or longer as mutually desired by mother and infant. And so that kind of leads us to our research question, where our primary aim was to determine whether the duration of exclusive breastfeeding is associated with childhood overweight and obesity, and whether this association differs among women who are overweight/obese pre-pregnancy compared to normal weight women. And so, again, this is a secondary data analysis, but some of the inclusion criteria within that was that all participants had to have a pre-pregnancy BMI. They also had to have a singleton birth. They had to have data on infant feeding practices, particularly breastfeeding duration and exclusivity, and a measure of childhood BMI between 2 to 6 years. The exclusion criteria, however, was any child born prematurely or children diagnosed with any chronic medical or neurological conditions. So the main exposure of interest is infant feeding practices, as well as the maternal pre-pregnancy BMI, while our outcome variables of interest include the childhood overweight obesity. We actually upped the age from 4, so it's now 2 to 6 years based on CDC BMI for age Z-scores. And this is an echo-wide analysis again. So DAC is thankfully doing some of that statistical analysis for us, in which for the primary aim, we're looking at utilizing linear regression models, again, to test that association between duration of exclusive breastfeeding and the child BMI scores, and we'll stratify those models by pre-pregnancy obesity status and adjusting for potential confounders. And so again, I wanted to just share a few results. The data has been harmonized and it's still being worked on, but this was some of the results that DAC kindly shared with us. And these are the characteristics of the child. So currently, the number of participants that had the variables of interest was around 7,982. And it was within 23 cohorts. As you can see, around 46% of those were female from the children. And then in terms of the BMI measurement, the median age range was around 3.5. And some of the socio-demographic characteristics, this is a pretty lengthy table, but one of the main things that I wanted to share is that the majority of the participants did identify as being white. A little over 50% were between the ages, or they were 30 and up. 31% had a bachelor's degree or higher and married. And this next table shows a little bit more about the maternal characteristics. 50% fall into either the overweight or obese category, and around 40% had no diagnoses of either preeclampsia or gestational hypertension. And also, we had around 53% that were also not diagnosed with gestational diabetes. There is a lot of missing that's hard to deny or not pay attention to, but we're still working through that with DAC to determine what's going on relative to that. And so some of the breastfeeding variables of interest for us, particularly for this question, as you can see, the breastfeeding initiation was around 90%, which was nice. And that was for 7,194 participants. However, as we look at breastfeeding duration, you can see the sample size drops a little bit. So in this table, it just shows that infants were mostly around 26 weeks when they were first fed any food or beverage other than breast milk or formula. And so this table, again, we're still defining our variables of interest, but DAC shared with, because again, one of our outcome variables is exclusive breastfeeding. And so they showed us, essentially this table shows the sample size of the participants. And as you can see, there is still a lot of missing within there, but the exclusive breastfeeding is through 3 months of age as well as 6 months of age, and it shows the most strict definition, and it leads down to, I guess, the least strictest definition, in which, as you can see, the most strict definition, there are a lot less in terms of the sample size, but we're thinking and deciding that we're going to move forward with the least strict definition, where the participants, where they confirm no formula, but allows for missing as well as unknown for foods and supplements. And again, there still is a lot of missing within there, which we're trying to determine how to proceed with that. So, and again, we're working with DAC to determine that, but this is just the very early stages of the results. And so some of the next steps moving forward, again, is just to confirm those breastfeeding outcome variables, as well as the definitions that we plan to move forward with for answering the research questions. Also, another step within that is that we need to confirm the sample of women who are overweight and obese, who also breastfed, and then that will help us to lead on and move forward with the final analysis. And if there are any questions with that, I'll stop here and stop sharing my screen and open it up for any questions. And then I can come back after to continue.
We'll have an opportunity at the very end of this to our meeting to have broader questions, but if you have specific questions on this one, please feel free to bring them up now. And if not, we'll move on to our second speaker, I believe is Jean, correct?
Yes.
Well, yeah.
Is that right?
Yeah, it is correct. I did want to mention, which I should have done in introducing Gail, that Dr. Shipp, that these are all people who are, these are all echo-wide proposals that are being led by one of our investigators. So just so everybody has that. Thank you.
Right.
Thank you, Tracy. And I believe I'm sharing my screen, so if you can't see it or hear me, somehow let me know. I just wanted to point out, since we're in the middle of a nutrition sort of set of topics here, that posted just a few days ago in NICHD's Director's Corner is this little reflection on the commitment to nutrition research at NICHD. So if you have any interest in nutrition and haven't seen this, I really encourage you to go take a look. And what we try to do with the ECHO work is complement other areas of NICHD. So there's a whole lot going on, and there are a whole lot of opportunities for us to capitalize on ECHO to complement that. So I just wanted to point that out. Dr. Shipp gave a great example of an analysis proposal for an ECHO-wide project where we in Michigan didn't even contribute any data. So she came up with a proposal, and that is working with DEC and leading a writing team. So that's not a requirement that your cohort even has to contribute data to the particular analysis. I'm going to give you an example of another way to plan an ECHO-wide analysis proposal, which is in the very early stages of a plan that I'm leading. And this is one where we began with a cohort-specific analysis, and then we're expanding it now to an ECHO-wide analysis, and then hopefully using that to build future ECHO-wide research plans. So this is the paper that was the cohort-specific analysis. This was published just in January of this year, 2021. And this was using ARCH data. So that's our Lansing-based cohort. And so very, very briefly, the rationale for this paper is that iodine is needed for the construction of thyroid hormone in the body, and it's very important during early fetal brain development. So it's really important to the fetal brain development. There are serious clinical implications. If you don't have enough iodine in adulthood, you get goiter. If you don't have enough iodine during pregnancy, you get what we used to call cretinism, is now referred to as congenital hypothyroidism. It's long been known to cause this iodine deficiency. In the 70s, there were actually trials to show that if you give, this child is from Papua New Guinea, where they did the trials to show that if you give iodized oil during pregnancy, you can actually prevent congenital hypothyroidism. So very important, still the single most important preventable cause of brain damage in the world. But our interest in the US is looking more at sort of marginal deficiencies, which recent work has been showing that in addition to these sort of more severe deficits from severe deficiency, there might be some neurodevelopmental deficits from milder deficiency. And you know, you may know that Michigan and the whole upper northern part of the US were part of what we call the goiter belt back in the pre-1920s before we had salt iodization, the iodization, the fortification of salt in the US. And you might be interested to know that the first iodized salt available in the US was in Michigan. We don't necessarily eat locally so much today. And of course, seafood and iodized salt are still good sources of iodine. But in the US, the biggest sources of iodine are from dairy products and bread products. And I'll show you some data in a minute to show that there are marginal deficiencies at the US level. So in terms of prenatal supplements, only about 58% of prenatal supplements contain any iodine, and only about 20% of US pregnant women are actually taking prenatal supplements with iodine. This is just published in 2020 by one of our co-authors, Elizabeth Pierce at Boston University. So this is an issue today. It's a contemporary issue. If you look at NHANES data, the National Health and Nutrition Examination Survey led by the CDC, you can see that in the early 70s, there was plenty of iodine in, I should say we measure iodine by assessing it in the urine. And then in the late 80s, there was this drop off. About 150 is the median value that we use to show that there's a population sufficiency. And you can see there's this drop off over time that it's kind of hanging around marginal. There's some reasons for that I won't get into related to food processing methods. So what we did, that you're all familiar with, our ARCH study, we were able to use multiple urine samples from our cohort and account for within-person variability and transform the data to approximate normality using some statistical methods that were developed for use in pediatric populations, but had never been used in pregnancy before. And Mike Elliott on our team is who conducted the statistical analyses. So one important part of our paper was showing this is how iodine is usually assessed at the population level. You look at median concentrations, and if the overall median concentration is above 150, 160 in pregnancy, then you say that your population is sufficient. And so if we had stopped here, this is what we would have found. Yep, looks like it's sufficient. No difference by trimester, no difference across gestational weeks. But using the methods, again, led by Mike Elliott, we were able to show that the actual prevalence of inadequate iodine was nearly a quarter, so 23%. Whereas on the other hand, excessive iodine was very rare. So this, again, sort of leads to an encouragement for supplementation for pregnant women, which it is already recommended by the Endocrine Society, one of the pediatric societies, but not by the Obstetric Society. So this is sort of part of what we're trying to influence. So our conclusion, of course, is that many pregnant women, maybe nearly a quarter, aren't consuming enough iodine, and it's an important nutrient required for brain development. So what we did is we put this right in the discussion of that paper, because this was published in AJOG. We're trying to influence the American Council of Obstetrics and Gynecology. So we put right in here that this would be important to look at across the whole US. And one way we could do this is by using ECHO as this platform. So that led right into one of the HERE ECHO projects led by Robert Wright and Susan Teitelbaum was the Exposome project that we're still sort of navigating through the details of which cohorts will provide which samples for which of these 6 exposure groups. But in this process, we have the subgroup working on this has approved iodine for iodine analysis on 2,000 urine samples. And so our ECHO-wide analysis plan is going to include 2 samples from 1,000 pregnant women from about 10 cohorts. So that's what we're working out details now. And then ultimately what we'd like to do is have additional, have that be a sort of long for additional ECHO-wide proposals where we pull in maternal and child thyroid levels and look at the associations between pregnancy iodine and those, and then ultimately child neurodevelopmental outcomes. So that is our plan. And I am going to stop.
Yes, well, I would like to start by thanking you for the opportunity to present today our eco-analysis proposal on behalf of my writing team and my writing team colleague, Dr. Mckee Buxton from the University of Michigan. I've said it before, I can't resist saying it again. I feel so extremely fortunate to be accepted in the CHARM family, to be part of ECHO, and to collaborate with all my colleagues at Michigan State University, University of Michigan, and Wayne State University. It has been a real pleasure. So my laboratory, my division at the Brigham and Women's Hospital studies how maternal health impacts child, mother, and family wellness. We research molecular and cellular pathways that are responsible for maintaining health, and they point us to factors that can be modified so that we can prevent or reduce the risk of disease. And no secret, through observation, we know that poor diet, stress, sleep deprivation, environmental toxin, all can affect not just our quality of life, but that of our children. But how does it happen? What are the nuts and bolts involved that we may control? So, and it turns out one of the main culprits is inflammation that occurs in the mother, placenta, fetal tissues, and from there is passed to the newborn. And when that happens, the future health of the child is harmed. So what have we learned about perinatal inflammation? It is now a mountain of evidence to show that inflammation that happens around birth perinatally is harmful. It can lead to a myriad of adverse pregnancy and neurodevelopmental outcomes, obesity, as well as autoimmune and allergy diseases such as asthma. With the available invaluable help of participations in the CHARM studies in this research, we are on the quest to determine what can we do to actually protect children from the harms of inflammation. We use biospecimens donated for our studies from the CHARM and other ECHO cohorts, particularly blood, dry blood spots, pieces of placenta, breast milk, to measure markers that can tell us if the newborn is experiencing inflammation, if the mother and newborn are experiencing inflammation. And what is the good news is that from studies in non-pregnant adults, we have learned that one of the best ways to fight bad inflammation comes not from the drugstore, but from our grocery basket through the right foods and beverages. Research has been conducted in, again, non-pregnant human populations, and important indices have been developed. The Dietary Inflammatory Index has been computed to quantify the inflammatory potential of the diet as either anti or pro-inflammatory, generating a numeric continuous variable validated against blood levels of commonly used biomarkers of inflammation, such as CRP and IL-6. This index has been used to evaluate the impact of diet on a few health outcomes in which inflammation is suspected to play a role. However, it hasn't been studied enough in pregnancy. Another index, the Empirical Dietary Index, has been developed and validated with the help of specimens from the Nurses' Health Study and the Health Professionals Follow-Up Study, using inflammatory potential assigned to validate its semi-quantitative food frequency questionnaire instruments. But again, very little or no information is available on how this impacts pregnant women and the perinatal outcomes. And now the question is, why can't we just take these indices, apply them to our studies, and be done with it? So they are really, why do we need to study our population, our pregnant population particularly, and not just apply what is already known about good and bad foods? There are a lot of unique challenges when we study inflammation in pregnancy. There is a unique pregnancy context to it. So when we look at the systemic inflammation in the pregnant woman, we actually see the contribution of both maternal, placental, fetal perturbations, and tissue origins. And there is a very complex maternal fetal feedback loop. Also unique to the timing of specimen collection in pregnancy is that we have timing related to the physiologic function and the hormonal and developmental regulation. So we have what we call the moving norm, because physiologically some levels of biomarkers of inflammation are changing for a good reason in pregnancy. And the kinetic of pathogenic inflammatory upregulation is imposed over this physiologic developmental regulation. There are gestational differences in half-life and clearance of inflammatory mediators in the blood plasma volume. And the mRNA output at the tissue cellular level may not correlate with protein concentrations in blood. So just one example, for example, CRP, C-reactive protein, well known to all of you, I'm sure, and used widely as a biomarker of inflammation, and in those for the calculation of those indices that I mentioned. It's produced by both the maternal liver and the placenta. And it serves to protect against complement-mediated damage. So it's actually not an evil creature. It actually has good innate immunity properties there, and normally rises with gestational age, especially after the placenta is fully formed. And there is a surge at birth or around birth. So CRP under placental fetal is under placental fetal regulation. It's lower in the intrauterine growth restriction. Is that a good thing if we see low CRP then? Maternal pro-inflammatory insult can lead to higher CRP, that then can lead to intrauterine growth restriction, that then can lead to delayed fetal development, that then can lead to lower CRP. So it's really complicated, and unless we study these processes in pregnancy, we cannot get the full picture. So to actually address this complex but very, very important and potentially big win question, we started this, we got this proposal approved by the ECO Publication Committee, effect of maternal diet on perinatal inflammation, targeting interventions to optimize fetal growth and attain term birth. It seems like a very ambitious title, and believe me, it is a very ambitious concept. So we need all of you to contribute, put your brains into it, because it's really important and complicated. So the main hypothesis that we are tackling here is that maternal diet, if we simplify it enough, maternal diet influences child health outcomes, and that happens through its potential to induce or mitigate harmful inflammation. And of course, our paper will focus on the newborn outcomes, so the early postnatal period, and we hope that what we will generate and build during the development of this proposal and this paper will help you, future investigators in ECHO2, to further address effective diet-induced perinatal inflammation on other health outcomes like neurologic, any other outcomes later in childhood or adolescence. So we hope this concept is actually paving the way. And it's important to remember that the pro-inflammatory potential of food may vary by maternal age, social determinants of health, body mass index, autoimmune disease, pregnancy-specific factor, gestational week. So we really need to address a number of confounders and modifiers while we are developing this concept. So this is what we are, in a nutshell, trying to achieve with this concept. We would like to identify inflammatory markers and patterns that correlate with maternal diet and birth outcomes that I mentioned. we would hope that that will help to design interventions such as based on anti-inflammatory maternal diet elements that could be evaluated in randomized controlled trials to further test the outcome question and lead to improvements in fetal growth, development, and gestational age, and to generate improved new evidence-based guidelines for perinatal care tailored to specific groups of women. And we even dare to dream, and that's a dream, but hopefully it will come true one day, that we will be able collectively to create a personalized interactive app to allow, there I said it up, my gosh, I'm a 20th century person, so I don't even know exactly what that means. But anyways, to allow pregnant women to determine what is the best diet for them to given their personal risks and characteristics like race, ethnicity, body mass index, comorbidity, sex of child, multiple gestations, all of these questions that we are burning to be answered. So, so what are our stepping stones? Where are we today? So what each of the eco-wide concepts needs, I guess, is data harmonization and data upload to DAC. And what we specifically need are the dietary exposures. Good news is that harmonization has been completed for most relevant dietary intake instruments. We need to upload the cytokine data, and I have been working with DAC to develop the data dictionaries and protocol and procedures that will be passed to the cohorts for upload of cytokine data. And we have already 2 cohorts who have agreed and are ready to pilot the procedure before the end of this year. And hopefully we will have the data in the February data lock. We also need the PPP outcomes, confounders and modifiers, and this process is ongoing. So DAC will be looking at that as soon as they are we have been working with a DAC investigator, Stefan Erhardt, with whom we met last week, and we are trying to put a time frame and when current priorities will be resolved so that the time will come for us to address the dietary inflammation, inflammatory potential concept and paper. So this is just an example of what we got from the January data log. We are still awaiting summaries from the August data log, where we hope to have a lot more completed data, but this is like, at that time, 4 cohorts had submitted data on the 24-hour dietary recall, and so DAC has crossed these cohorts, the number of participants in each, and missingness in variables like birth weight and gestational age. You would think by now all of this would be uploaded because they have been harmonized, and it's just a matter of priority. So as soon as DAC clears their priority list and comes to us, we will be able to send requests to cohorts who and gives us the data log, August data log data. Then we will be able to see where our missingness is, and maybe we will be, we will be actually contacting cohorts to see if they could, if they have more data that they just simply didn't get to uploading, that they can actually upload before the February data log. And this is a big thank you to our writing team on behalf of me and my wonderful, wonderful collaborator and colleague, Miyata. You can see it's a huge list, so hard to mention every name. And of course, thank you to the CHARM research team. And now, if we have questions, I'm happy.
Fantastic. So I'll be talking with you a little bit about EC0241, which as we speak is with the publication committee, has been for just a couple of days. So cross your fingers that that goes well for us. You'll notice that the title is pretty different from the title that you see in the agenda. Our focus has gone through a number of iterations as a result of what we found in the data, meaning we didn't necessarily have the cell sizes when we wanted to drill down and look at what we wanted to look at. So we started with looking at non-pharmacological interventions and their effect on length of stay among infants with neonatal opioid withdrawal syndrome. Because we have almost no infants in the extant data with documented neonatal opioid withdrawal syndrome, sometimes also similarly called neonatal absence syndrome, we went instead to looking at just breastfeeding amongst opioid exposed infants. Didn't have the cell sizes for that, so it became looking at opioid exposure's effects on length of stay, along with that of some other substances. So that's kind of why the difference in what you see there. This is happening as a result of the ECHO NOWS subgroup. A little bit about that subgroup. It resides under the neurodevelopment and PPP working groups, and it was designed as a way to support development of concepts specifically related to NOWS, given the importance of opioids and opioid exposure and its effects in pregnancy. However, as I mentioned a moment ago, the extant data had far too few cases of NOWS to support any kind of meaningful analysis. So we have since expanded to looking at opioid exposure as a binary variable, and also looking at exposure to alcohol, tobacco, and cannabis, with other exposures being too infrequent to be analyzed in the current samples, even with the latest August data lock. So what you're going to see here is a result of kind of that new focus based on the data that we actually have. Very excited about the data looking forward. And I should say also that one of the jobs of the ECHO NOWS subgroup was to make recommendations about the ECHO-wide protocol in terms of how to measure substance use and have those data available for analyses from the prospective data collection. So I will say it is partly my and Barry's fault and that group's fault for the fact that you're having to get urine samples and hair and or meconium, et cetera. That's going to be invaluable for us as a way to measure substance exposure, both in an objective way and over time at various trimesters. So this is with an older data lock, but just to give you a sense of what the harmonized data look like using the approach that we've used so far, you'll see here that we have data on a fair number of infants in terms of just having opioid exposure, with only, as of this data lock, about 562 of a much bigger sample being positive for any opioid exposure, and only a very small number of them being positive for actual NOWS or NAS. Obviously much bigger numbers for alcohol and tobacco and cannabis, so that gives us much more to work with overall, and pretty small numbers for illicit drugs other than cannabis. Just quickly, this is the data harmonization process that the DAC has gone through in terms of opioids, which we followed with other substances. Pretty long process trying to scour the available forms for any mention of especially toxicology testing, but also treatment, self-report, anything that we can find giving us an indication that exposure was present. But that's as much as we've been able to do in a harmonized way. In other words, we don't really have good data on dosage or extent of exposure. We don't have good data on timing of exposure, even at the trimester level. So the variables that we're talking about as a group and that I'll be presenting today are simply a dichotomous yes, no, was there any evidence for exposure in this particular participant. So in terms of background for the study that we did end up doing, that being looking at the association between substance exposure, especially opioids, and birth hospitalization length of stay, there's plenty to tell us that infants with NAS or NOWS have a longer length of stay. And that carries lots of risks, including financial risks and risks regarding early attachment and social risks. However, there's been almost no work looking at the effects of just mere exposure that falls short of NAS or NOWS and its effect on length of stay. The assumption is that any exposure is going to be associated with a longer length of stay, not just for policy reasons, but also because of effects on birth outcomes. But the data aren't there to really show that. And importantly, there's not good information to show the extent to which mere opioid exposure is associated with NOWs. In other words, what proportion of cases. This pie chart that I'm showing you here is not from a study designed to look at this, but it is from the best example I could find in which investigators reported both the proportion of their sample with any opioid exposure at any level and the proportion of their sample diagnosed with NOWs. And as you see here, it was a pretty small percentage of the overall opioid exposed pregnancies that actually resulted in NOWs, at least using this, almost back of the napkin approach here, suggesting that many of the opioid exposed infants are going to be exposed rather than meeting criteria for NOWs, and we need to know a little bit more about them. Then finally, in terms of background, this area is rife with methodological problems that have had serious consequences. So far too often, investigators seem to want to show negative effects as a result of substance exposure and don't necessarily control for confounds that need to be controlled for. This is true historically and led to a lot of serious problems early on. Just think of the faux problems in terms of exposure to cocaine in infancy. We know a great deal more now, and yet investigators don't always follow those what we know to be better procedures and don't always report accurately. So we've seen plenty of cases where the adjusted analyses show no effects, but the abstract reports on the unadjusted analyses and makes recommendations on that basis. So we wanted to do it right. And then finally with ECHO, we had an opportunity to not have just a regional cohort, but a much broader cohort. So our aims were first to look at the extent to which any opioid exposure is associated with a longer birth hospitalization length of stay, especially when we use propensity score weighting to do a rigorous job of controlling for potential confounds. Aim 2 was to do a similar analysis, but bringing in other substances, whether alone or in combination with opioid use. And we predicted that we would see a longer length of stay for infants exposed to opioids at any level, and that would be even longer when they were exposed to additional substances like tobacco, alcohol, or cannabis. So from 8 cohorts, we wound up with a sample of 5,989 infants from 5,927 pregnancies. Our measures were opioid exposure, tobacco, alcohol, cannabis, and length of birth hospitalization. We used the mice package in R to impute missing data where appropriate. We used propensity scores using the R package twang to control for confounds, and then used linear regression to look at the association between exposure and length of stay. So table 1 is pretty long. I have it here for you in 3 separate parts. Overall, not too much to say. This is specifically looking at the non-NICU samples. So any cohorts that were focused primarily on infants who were in neonatal intensive care were excluded from this. We looked at them separately and didn't find much different and ended up focusing just on the non-NICU cohorts. Overall, this was a fairly diverse sample. Prenatal opioid use, according to our definition, in 3.3% of cases, 6.6% showing evidence of cannabis use, 15.5% for tobacco use. And so far, this is fairly consistent with what you would see in typical samples for prenatal substance exposure. Alcohol for 41.3%. That's much higher than you would normally see. One of our cohorts that contributed a significant number of cases to this analysis was specifically focused on alcohol exposure in pregnancy. And then finally, you'll see here that just over half of cases in this particular sample showed no exposure to any prenatal substances, 35% to one, almost 11% to two, and 3% to three substances. So in terms of the adjusted analyses using propensity score weighting, we found no differences in any of the substances for length of stay. Little bit suggestive difference here for opioids and just over a day, but wasn't statistically significant, and nothing else for any of the substances. And that includes in our AIM-2, where we looked at opioids only, opioid plus another substance, other substances only, or no substance exposure at all. Again, something a little bit subjective here in the opioid only, but not statistically significant, partly because of these cell sizes here. So our conclusion essentially is that when you look at substance exposure as this very simple yes, no, it doesn't seem to be associated with birth hospitalization length of stay. That was contrary to our expectation, and is frankly contrary to a lot of expectations in terms of outcomes for substance exposed infants, for whom those sorts of expectations tend to be exaggerated and not consistent with what you see in the literature. We think that there's a lot more to be done in terms of looking at dose response effects and effects by trimester. And we're looking forward to using the prospective data to perhaps do a little better job of that. So that's what we have. Thank you. Happy to take any questions.
Yeah, are there any questions for Steve? That was fascinating.
Okay, thank you. So just continuing on, I'm back. I'm going to share a little bit of my progress and some developing results from the second component of my supplement. And again, this is under the mentorship of Dr. Jean Kerber, and it's titled Understanding Breastfeeding Practices Before and During. We're not over, so not after, well, we're still in the pandemic. So yes, let's see. Can I move this though? All right. So just to give a little bit of background, as you all know, because we're all in the era of COVID-19 and still learning and coping with it. But relative to breastfeeding during COVID-19, it is considered a sustainable practice, and it can be very valuable, potentially during shortages or challenges in obtaining formula, bottles, or other infant feeding supplies. And so I talked a little bit about the benefits earlier, and while there are many of them benefits associated with breastfeeding, which makes it a very important preventative health measure, that initial phase or the early era of COVID-19 really disrupted everyone's lives and demanded pretty quick actions and changes. And with that, some of the potential cause to those changes really could have impacted or having varying breastfeeding experiences within the United States and abroad, which may also be dependent upon socio-demographic characteristics. And so that led us to our next research question of interest, wondering, well, will the era of COVID-19 pandemic affect breastfeeding and initiation and duration rates, in which our first aim was to determine whether initiation and duration rates of ECHO participants differed prior to, as well as during the COVID-19 pandemic, in which this aim is ECHO-wide. And then I had an additional aim where I wanted to explore the decision-making experiences regarding infant feeding practices of ECHO participants who are still pregnant or breastfeeding during the early phases of the COVID-19. And this one is more cohort specific, using March participants. And so I'm going to focus, sorry about that, but the AIM-1 is still in development. and we're working with a DAC representative. But today I'm going to focus a little bit more on AIM-2 because that is the analyses that I've been able to spend a little bit more time on and I'm conducting myself. And so in order to move forward with that, so with the data collection, we put some screening questions in which we added them to the 9-month interview to see, particularly to see if COVID-19 played a role in any of the women's either decision to breastfeed or continue to breastfeed. And if they were asking or requesting if they would be willing to share those experiences through a 15 to 30-minute interview in which I held those interviews with the women. It was a semi-structured interview that was conducted in which this is the participant interview guide in which we asked questions, again, related to how COVID-19, allowing them the opportunity to describe their experiences, whether it provoked any emotions relative to the decisions to breastfeed or continue breastfeeding, if it impacted or affected women being able to meet their breastfeeding goals set. We also asked a little bit about their perception of social support during COVID-19 and how that may have impacted their breastfeeding experience. And we also asked a little bit in regards to their hospital experience. And so I'm still working through the data analysis. I also have an undergrad that's assisting me with that. So we're doing the coding of the transcripts, but I just wanted to share a couple of brief results. So from one of the questions where their breastfeeding experience, the question was focused on breastfeeding experience during the pandemic. A developing thing that I noticed that came from those interviews is that the women still had the typical breastfeeding challenges and negative feelings that you often find within the literature, but we noticed that it may have been heightened due to the pandemic, particularly some of the stringent hospital procedures. And they also shared having positive breastfeeding experiences as well. And so just briefly, again, the negative feelings and breastfeeding challenges are, again, normal and you can find them within the literature, but it was interesting to hear some of their feedback in regards to not being able to have a visitor. One mother mentioned about she returned back to work and not being able to take as many breaks as in order to pump. It was short staffed within the hospital. They would have liked more support. However, they mentioned some positive experiences relative to the pandemic, which that having those support groups, particularly Facebook, which was instrumental in support. One mother mentioned being able to restart breastfeeding again because she was able to return back home and work from home. And so that was some interesting findings. And then in one other question, how did COVID-19, what was the role that COVID-19 played in the decision to initiate breastfeeding? And the overarching, and still this is developing, but what we could find is that the mothers really want to do what's best, but there were some concerns regarding the pandemic. And so one mom mentioned being able to have the vaccination, which would make her feel more comfortable to breastfeed. Obviously, they feel that breastfeeding is healthy. They felt that one mother mentioned feeling like she was able to do more or to keep her baby healthy because of those antibodies. She felt the antibodies would be present within her breast milk and being shared to her infant. And just another question or some results to share, their perception of support received. Again, the theme is developing, but what we could find so far is that it seemed as if breastfeeding support was limited. And so one mom mentioned having a virtual consultation where she had to pay out of pocket and having difficulty with retaining information from the lactation consultant. Another mom mentioned that her breastfeeding goals were not met. And another one mentioned, same along with that, just the not being able to see a specialist in person to get her breast milk or her supply back up. And so in regards to both of the aims, relative to aim 1, I'm going to continue working with DAC. Which is nice, is that the same outcome variables that I presented earlier, there will be the same variables that I will use in this manuscript. And so confirming those breastfeeding outcome variables and those definitions will definitely help in terms of completing the final analysis for this aim. And then this manuscript is still in progress. And regarding aim 2, I want to continue to collect data, particularly to increase the sample size and in terms of helping to reach data saturation. And along with that, we will finalize the analyses, and the manuscript is still in progress for that one. And so I definitely want to acknowledge and thank the ECHO participants, the CHARM study office for all of their help during this time period. My main and primary mentor and the PI for this study, Dr. Jean Curver, my co-mentors, Dr. Paneth and Dr. Comstock and Dr. Misra, and then lastly, NIH for the funding to support me during this time.
Appreciate that. I have to run and pick up kids at 3 o'clock, so. Today, I'm going to be talking about the relationship of microbiota to child health outcomes. My name is Sarah Comstock. I'm an assistant professor here at Michigan State University in the Department of Food Science and Human Nutrition. And I've been involved with the ECHO microbiome aspect since the beginning of ECHO, when we were working on developing the protocols and deciding which microbiome samples we wanted to collect from these children. Before I dive into the microbiome, I just want to say that I've participated in several ECHO-wide writing teams, and 2 of those writing teams have actually published their results already. One was an Understanding Environmental Influences on Child Health Across Generations, which was more of a review and perspectives article. And then another, The Disparities and Risks of Inadequate and Excessive Intake of Micronutrients During Pregnancy, which was an analysis of pregnancy dietary data in ECHO. But for today's purposes, we're going to talk about the microbiome, and I just briefly want to remind everyone what our microbiomes are and why they're important. These little microbes live on and in us. I'm most interested in those microbes living in our gastrointestinal tracts. These come from exposures such as mode of delivery, what kinds of foods you're eating, whether you're taking medications like antibiotics. But they're also dependent upon your genetics and other host-associated factors, and partially dependent on the microbes that are present themselves. And so over time, as an infant, this microbial community is disorganized, but there's fewer microbes present. As you age and start to eat a more adult-like diet, these microbes in your gut kind of stabilize, and you've got the community that you might have throughout life. And we think that this developmental trajectory is really important because these microbes living in your intestines contribute to the maturation of your immune system and also the development of your metabolism and other metabolic processes. So right now, all ECHO-wide microbiota analysis proposals are on hold, and this is one, due to fatigue amongst cohorts with setting up data use agreements. Everyone had gotten tired of developing a data use agreement for each study that they were going to be participating in, and kind of put their foot down and said, look, this needs to go on the DAC platform so that we can just access this data without doing all this additional paperwork. Currently, DAC has a draft SOP. That is what we are waiting for them to finalize before we can get started running these microbiome associated analyses. Once this SOP is in place, which hopefully will occur shortly, cohorts will be asked to upload their microbiota data. And at that point, then we'll start to be assigned DAC analysts to help with these microbiota related projects. So the current 2 microbiota-related ECHO-wide analyses that I'm helping to co-lead are EC0446, which is the infancy gut microbiota and childhood obesity, which I'm co-leading with Kathy Lee Sarwar from Carlos Camargo's group at Harvard. and EC0393, which is the relationship between the gut microbiome and child anxiety and depression in middle childhood and adolescence, which I am co-leading with Vanya Klepak-Siraj from the Dietary cohort up in New York and Rhode Island. But both of these are on hold right now. We also in CHARM have a number of microbiome related echo projects that have been funded. So last year we landed a COVID NOCI project where we are looking at microbial mediators of the impact of maternal psychosocial stress on perinatal and neurodevelopmental outcomes. And there are 3 microbiome OIFs associated with our cohort. One is actually being led out of the DAC at Johns Hopkins by Noel Mueller, where we are using echo data as a platform to study mother to infant vertical transmission of the microbiota. And we're a subcontract on that to do some shotgun metagenomic analyses on existing samples. Of course, Michael Petriello at Wayne State University was also awarded an OIF, where he is understanding the impact of environmental chemical exposures on gut microbiota and microbiota-derived metabolites in both mothers and children, using some of the gut samples that we've collected here in CHARM and also samples from other cohorts. And then finally, Kim Mckee has an OIF. She's at the University of Michigan, where she's validating maternal vaginal microbiota signatures in pregnancy using a number of echo cohorts and the vaginal microbiome data that they have. So for Kim's award, she actually has executed DUAs with all of the participating cohorts, and they are doing those analyses at the University of Michigan. But Noel and also the COVID NOCI, we are trying to work on the DAC platform to avoid some of the paperwork that's required there. And so we are waiting for that SOP to be put into place to make progress. Meanwhile, also associated with the COVID NOCI is an echo-wide paper related to maternal psychosocial stress and perinatal outcomes. And this is related to another echo proposal. So the NOCI associated proposal is EC0413A. And then later, Allison Hipwell and Irene Tung proposed EC0445. And you'll see that there is quite a bit of overlap in the proposed NOCI topic and the EC0445. And you might wonder, well, how does that work in ECHO if there are 2 ECHO-wide proposals that are very similar? Well, the publications committee will tell you to get together as a group and work it out amongst yourselves to figure out either how to merge your writing teams or how to basically differentiate your 2 analysis proposals. So several months back, members of the writing team met and we laid out a plan to differentiate the 2 analysis proposals. And you might remember my science talk at one of the ECHO-wide meetings earlier this spring, where I presented EC0413. We're looking at the impact of exposures such as the pandemic on psychosocial stress during pregnancy and how that relates to birth outcomes. And we are really interested in how the pandemic period maybe differentiated the experiences of psychosocial stress during pregnancy, which then might have led to differences in birth outcomes. And EC0445, so that's the other writing team, decided to look at modifiable protective factors that might have prevented or decreased some of the psychosocial stress that was being experienced during pregnancy during the pandemic. And they were going to look at sleep and physical activity as the 2 main modifiable protective factors. So for EC0413, which is our COVID NOCI project, we used propensity score matching on maternal characteristics, including race, ethnicity, education, income, and age, as well as child age, to create a pre-pandemic group and then a pandemic group. And we define the pre-pandemic group as existing from January 1st, 2016 through February 28th, 2020, and the pandemic group existing from after 2/28/2020 to the data lock in June of 2021. And so what we saw on the propensity score matched populations is that there was no association between the pandemic and birth outcomes such as birth weight, gestational age at birth, or adjusted birth weight. However, in models that included depression we saw that when we took into account both depression and the pandemic, that depression was associated with a decrease in gestational age at birth, and that the pandemic was also associated with a decrease in gestational age at birth, as well as an increase in adjusted birth weight. However, in models where we included perceived stress, then the pandemic was only associated with a decreased gestational age at birth. And the effect size was quite small. That decrease was around 1 day, so very small effect size. But consistently taking into account these psychosocial stressors, we saw a decrease in gestational age at birth in the pandemic group compared to the pre-pandemic group. Working echo-wide, you'll see there's a few issues. Mainly, you think you might have thousands and thousands of cases, but as has been pointed out previously, there's a lot of missingness on the DAC platform. And so your sample size quickly shrinks. And unfortunately, so we have our COVID NOC paper drafted and our results all put down on paper, but now there's a concern with the other writing team that they may no longer have a paper unless we change how we've presented our results in the EC0413A. It's a little complicated because the two writing teams have different participants. EC0445 has an even smaller sample size. We have about 1,000 pre-pandemic pregnancies and 500 pandemic pregnancies. They have even fewer, and they were not able to look at sleep as a positive modifier. They've only been able to look at physical activity as a positive modifier. So we're just now trying to figure out how to navigate these issues and separate the two analyses. And then I'm also working on writing teams for several other echo-wide analyses, but most of these are related to birth outcomes and are not related to the microbiome. And with that, I can take.
Sorry, I'm trying to get the, there we are. All righty, so yes, I think I can speak for myself and Nigel and Jean in my hopes that this is the last time I will be presenting this as something that we are preparing to do, and maybe something next time we can be presenting this as something that we have done. So this proposal has been in the works for quite some time, and all of those problems that Sarah talked about, we probably contributed to some of those for this particular proposal. So we are going to hopefully this one last time talk about what we're going to be doing, and no, it looks like potentially early this year we'll actually be able to do the analysis and get this in the works. So the title of our analysis proposal, EC0379, is the relationship between maternal herpes virus infection and autism behaviors in children. So when I was running my lab at MSU, I was very much interested in understanding how rather common viruses, herpes viruses, affected the maternal immune system, how they interacted with the pregnant host, and how those responses might be affecting the in utero environment and fetal development. And so we did a pilot study to actually look at this based on some of looking through the literature. We really, we determined that there was really a lack of data in the population data looking at these viruses during pregnancy. And so some of the stats out there, if you consider cytomegalovirus, which is a common herpes virus, its prevalence is between 40 and 60% of people in the US. So it's a highly prevalent virus. And yet most of the research has focused on CMV as a congenital infection. So most of us have heard of congenital CMV, and this occurs when CMV in the mom actually crosses the placenta and directly infects the fetus in utero. And this, of course, can lead to very significant birth defects and outcomes during development, but this is very, very rare. 0.5 to 2% of cases actually end up being leading to congenital infection, because the placenta is actually quite good at protecting the fetus from these infections. But what we are really interested in is seeing how moms that had these infections that did not actually cross over the placenta, how those maternal infections and the response to those infections actually affected the environment. So basically hypothesizing that, an inflammatory response to these infections that were often asymptomatic might actually be affecting the in utero environment and resulting in changes in neurodevelopmental outcomes. So we know that CMV reactivations do occur more often during pregnancy. They elicit an immune response, but we know very, very little about what this response looks like and how it affects the fetus. So this led us to hypothesize that maternal immune activation can adversely affect fetal neurodevelopment. And therefore, we developed a pilot study using the ARCH development cohort to test the hypothesis that maternal CMV, and at that point, we were also looking at HSV2, to test the hypothesis that these viruses were associated with greater risk of children developing behaviors related to autism spectrum. And we used SRS2 scores that were performed on the children in that cohort to test this hypothesis. And so this pilot study we did several years ago. Again, this was a study subsample of about 132 maternal child dyads using, again, the ARCH development substudy. We again tested this hypothesis that maternal CMV seropositivity would be associated with more significant or severe ASD-like behaviors in children. And I'm not going to go over this in too much detail, but our basic study protocol was, it was pretty straightforward. We basically took moms that had blood collected during the first trimester. If they had a single-term pregnancy over 18 years of age, English speaking were inclusion criteria. If we had those, we then looked, and if they had a child assessment for SRS2 and the child behavior checklist, we incorporated them in this study. And the very basic and straightforward design of this was we basically performed ELISAs to look and see if moms had CMV IgG or HSV2 IgG, indicating that they harbored one of these latent infections. So these were collected at the first trimester, and then again we basically performed analysis, linear and we performed regression analysis to look at the relationship between the seropositivity and the SRS2 scores in the children, looking at those scores on a continuous scale. And so taking a lot of data and analysis and just putting it here. So this was basically the results of that study that was published in AJRI in 2017. And basically what we found was that HSV2 IgG in the maternal serum did not have any relationship with SRS2 scores in their children between 3 and 5 years of age. Yet CMV IgG seropositivity did indeed have a positive relationship with ASD severity or SRS2 scores, with the beta values in our unadjusted model being a mean of 3.8 points higher in women that were positive for CMV IgG. And this was robust to adjustments for a number of potential confounders, including age, child sex, et cetera, listed down here, as well as a second adjustment model where we actually included the child behavior checklist scores that looked at both the several different other behavior domains to determine if this effect was specific for autism-like behaviors. And this was robust to that adjustment as well. So the goal of our analysis proposal here was to go from that rather small pilot study that had 43 samples and 38, about 100 basically we end up having actual dyads to study. The point of this was to really bring up that first of all, a more diverse sample, and then also get an increased sample size to see if this held up in a larger population. So really, the description of that pilot study is very much what we are doing here in this proposal, but again, with larger numbers, and we also are incorporating a couple different hypotheses. So again, the study goals are, if you look at hypothesis 1, this is very much what I just talked about with our pilot study. And so our first goal is to test the hypothesis that maternal CMV seropositivity is associated with more severe ASD-like behaviors. Our second here is because, again, we're now incorporating the larger ECHO group. We have 5 different cohorts participating in a lot of maternal demographic and environmental data. So we kind of expanded our questions and wanted to also include this hypothesis too, which is to not only look at that primary analysis of the relationship between CMV and ASD, but also look at a number of the co-exposures that are available to us with all these cohorts and see if any of those quote unquote inflammatory co-exposures, which we'll go over in the next slide, actually influenced or affected that relationship between serostatus and ASD scores. And this really stems on kind of this hypothesis that an additive inflammatory insults might increase the risk of having, neurodevelopmental issues. So, the idea here is, if you have a viral infection that might be causing inflammation, if you also have other co-exposures that are adding to that inflammation, does that make that relationship stronger in that context? And then finally, hypothesis 3 really ended up being a second proposal, which I basically all put into one for simplicity and time's sake. And that really, because and this goes to something that Sarah mentioned before, a lot of the cohorts list having inflammatory cytokines already performed on the maternal pregnancy samples. Now, I'm not sure in the end how many actually are already done, but because some of the cohorts do have that, we included this third study, which will basically look to see if maternal cytokines act as mediators to mediate that relationship between CMV and autism behaviors in children. And again, so at this time, we have 5 different cohorts, and this is definitely the final groups that will be participating. So we have our own, which we're looking for, which we proposed would be an additional 60 to 100 samples that we've now gathered in the March cohort. And this is, of course, in addition to the work that we did prior. We also have, so Earl 1 and Marbles are very exciting for us because these 2 cohorts actually have a special population. So these are siblings of children who have already had a clinical diagnosis with ASD. So this is a special population to look at this relationship with. And then we also have New Hampshire and Emory who are contributing samples. So again, this ends up being about 1,000 samples. Originally it was going to be 1,500. But again, like Sarah said, as we kind of got through this, the sample sizes got a little bit smaller, but it still looks very excitingly to me like we're going to have about 1,000 maternal child dyads to test these hypotheses. And to not take too much time, I kind of did a graphic of those different hypotheses, but just again, to show you, this is the first hypothesis. The second one here, I just want to go over this because I didn't mention what these were, but here's that second hypothesis where we want to test how that relationship might actually be modified by co-exposures. So we have several that are collected as part of the main ECHO protocol, and that is the presence or absence of chronic disease, inflammatory diseases. We're doing some inflammatory diet specs, and this is with help from Jean in our own cohort, and then Kristen Lyall, who studies this, and she's at Drexel. And then we also are looking at stress and depression scales, and might even have a sub-cohort where we might actually be doing cortisol analysis of hair, because someone accidentally included that in this analysis proposal. And then we said, wow, that's actually a really good idea. We should do that. So that's something that we might also be doing. And then of course, the third hypothesis, incorporating into this model, we're putting these mediators, which are inflammatory cytokines in mom that, we propose might be mediating the relationship between the CMV outcomes and some of these co-exposures. So our team is huge. I think at this point, there's over 20, there's probably 25 or so members of the writing team, amazing group of people who were very excited to do this. As Sarah kind of mentioned again, this took a long time. So these were MTAs and DTAs with all of these cohorts, as well as getting biological specimens. Can't thank all of these PIs as well as our own enough. And so as of right now, we have all of them except the UC Davis samples. And I think we might stick Nigel on them one more time. And then also the DAC is actually going to send an email over there too, because they're also excited to see our amazing data. So I have a lot of faith in the fact that a year from now, I'm going to actually have results and not have to give you the same presentation. I swear, Nigel. So with that, thank you all very much for your attention. I appreciate it.
I'm going to switch gears and talk about more of a chemical environmental exposure, and I'll explain what it is in case you don't know. So I'm leading a paper that's focused on the impact of prenatal PFAS exposure. By now, you've probably heard about PFAS, but in case you haven't, this stands for per and polyfluoroalkyl substances. This is actually a class of chemicals of which there are possibly more than 9,000 different types. And there are, a few that we know a lot about and that have been found in drinking water almost everywhere throughout the entire United States. And we now know that it's found in other products like some food packaging and waterproof gear and all kinds of other things. And the real problem is that this chemical is really, really hard for it to break down. They call it forever chemicals. So because of that, if the environment has ever been contaminated with PFAS, then it stays there. It can get into your groundwater, and it's hard to clean up from your water system unless you put in a very special procedure to do so. In the map of Michigan here, every purple dot is an area where PFAS is known to be in the groundwater. So that just gives you an example of how much of it is all over the state. And we know this, of course, all of you are familiar with the DOHAD paradigm. We often think of DOHAD as applying to just, diet and malnutrition and early environmental factors like that. But there's also a lot of evidence now that chemical exposures, including potentially PFAS, that infants have or fetuses have in very early development can lead to, changes in cellular phenotype that maybe manifest later in differences in behavior, outcomes in infants, and eventually down the line are linked to adult, health outcomes and problems. And PFAS in particular is linked to low birth weight and preterm birth and changes in childhood growth and adiposity and potentially neurodevelopment. A lot of this research is still being worked out. But in this particular paper, we're looking not at a specific outcome in PFAS, a clinical outcome, but instead epigenetics, which could be a possible mechanism linking this early life exposure to, subtle biological changes that eventually lead to disease or developmental problems. And in case you haven't heard much about epigenetics yet, epigenetics you can think of as being heritable, but still reversible, changes in gene function that occur without a change in the sequence of DNA. So these are things like DNA methylation and non-coding RNAs and histone modifications that affect how the DNA is packaged and how it's accessible for transcription. So it doesn't change your sequence, but it changes what genes are turned on and off. Another way I like to think about it and to compare genetics and epigenetics is with a music metaphor. So you're all familiar with a piano or a keyboard, which you can think of as being like the genome. The genome or a keyboard has the same keys, the same code that you can find, on every piano you come across, much like that within an individual. Each cell of your body has the same genome. However, we know that a piano can be used to express and play, millions and thousands and millions of different songs. And much like that, your genome, that one code, can be expressed in many different ways to have different phenotypes and different outcomes. So your epigenome makes your liver cells different than your neurons, but it can also make a healthy cell different than diseased. And because of that, it's a really, really important thing to consider anytime you're thinking about development and the impact of environmental exposures too. And so that's the brief background, but the question for this ECHO-wide paper is simply, do prenatal exposures to PFAS change epigenetic profiles and specifically DNA methylation that we can measure in samples collected from newborns? And more specifically, we hypothesize that these prenatal exposures will associate with changed methylation at genes that are important for early life growth, metabolic programming and adiposity, and immune function. And we hypothesize this because these are some of the more outcomes that have been linked to PFAS exposure in the past. And based on prior literature, we also think that some of these associations might differ by offspring sex as well. And if you're interested in knowing some more of the details of how this is going to go down, we're conducting what we're calling a mega-analysis or a pooled analysis, looking at all cohorts that have PFAS and newborn DNA methylation data. And first, we want to identify specific genes that are differentially methylated by PFAS, then use that information to see if those genes are in common pathways and figure out what those biological pathways are. And we'll also be doing stratified analyses by sex as well. And as far as what data exactly we will use, for PFAS, as I said, there's 9,000 of them or more, but there aren't actually that many that are typically measured in human samples. For instance, for cohorts that are getting their samples analyzed by HERE or CHEER, the PFAS panel, I think, used to include 9 and now it includes 13. And some of the cohorts had their PFAS measured longer ago, and they might have only measured 4 to 6 of them. And with that, the PFAS data is actually what we're waiting on to get this paper started. It's not uploaded to the EAW yet, but once it is, we can get started. And I'm anticipating, based on talking to the cohorts, that we'll probably have 7 to 9 PFAS that are in enough of the cohorts that we can look at them individually. And we're going to take measures. We prefer early pregnancy, but we'll take measures from any time during pregnancy. And as far as epigenetics is concerned, we're using cohorts that have data from either cord blood or newborn dried blood spot samples that was generated with the Infinium bead arrays. And these give data at least 400,000 different loci throughout the entire genome. So it's big data. And the analysis plan, this is kind of a crude DAG here, but some of the potential confounders we identified in this relationship are things like parity and pre-pregnancy BMI and race, ethnicity, and smoking that we plan to adjust for in our analysis when the data are ready. And so far, just doing a quick screen before all the PFAS is officially available, we've kind of estimated there's a little over 1,000, possibly up to 1,500 that will have this DNA methylation data and the prenatal PFAS that we'll be able to include. And we also plan to use Vasantha Padmanabhan's cohort MIP as a replication cohort to see if the sites that we find replicate in another cohort, outside the data set. And you can see here that ARCH is the one of, our Michigan charm that is able to be included based on the data that they have. And so far, they're the only ones with blood spots, but blood spot data is usually fairly well correlated with cord blood data. And then this is, I believe, my last slide, but the potential impact of these findings are that when we incorporate epigenetics into environmental health studies, this can really help us with risk assessment of toxic exposures, because it allows us to look at more subtle impacts before you see some big clinical outcome later on in a population. It can help us to understand some of the mechanisms of toxicity, and hopefully also help with prevention and intervention strategies to, either reduce some of these harmful exposures in populations, or, potentially epigenetics could be developed into a biomarker, of risk. You might be able to measure DNA methylation at a gene and know that if someone has it methylated, they're at high risk for some outcome later on, and you could do some preventive strategies to help that person. And that's a way we hope the field will eventually go. And like the others have said, this is a very large writing team, and they've been, very helpful and patient while we've waited for the data. And I think we have our analysis plan really ready to go once those data are here.